Speed control of DC shunt motor using single phase of wave thyristor. It consists of a diode bridge which converts AC into DC. The shunt field winding is directly fed from bridge rectifier. The armature of the motor is fed from bridge rectifier through thyristor. The armature voltage is controlled by varying the firing angle alpha. The FD is connected across the armature to provide a circular path which stores energy in inductor during the period of thyristor turn off. At W2 is equal to alpha, the thyristor is triggered, output is obtained, the current waveform will go zero behind why due to the presence of inductance into armature wind. ఇదైనా రాయొచ్చు ఇది కూడా రాయొచ్చు. Speed control of DC shunt motor using single phase full wave rectifier. The speed control of DC shunt motor it is done by connecting two thyristors back to back. Here a diode bridge rectifier converts AC into DC during positive half cycle. T1 connects and supplies voltage to motor. During negative half cycle, thyristor T2 connects and supplies the motor. The DC voltage applied to the motor is varied by firing angle alpha. Diagrams neat ga anni. Next, explain the construction and working of SCR. Construction. Threaded stand, anode, aluminum, gate terminal, cathode. It is an important type of power semiconductor device. It consisting of four layers. These PN junctions within terminals, anode, cathode, and gate devices. The terminal connected to P region is called anode. Of the terminal is connected to N region is called cathode. And the terminal connected to inner region is called gate. It is an unidirectional device working. Net diagram and the two transistors model is obtained by setting the two middle layers shown in figure as a dotted line and it is separated in offs. The junction J1 and J2 and J3 are J2 and J3 are considered as PNP and NPN transistors, which is represented in circuit. That is equal to IC1 is equal to alpha A plus ICV not 1. The transistor Q2 IE is equal to IK IE, IC is equal to IE2, IC2 is equal to IK plus B naught T. The total current I at Q1 sum of two collector currents of two transistors I is equal to IA IC1 plus IC2 IA is equal to alpha 1 IA plus ICB naught 1 plus alpha 2 IK plus ICB naught 2. Explain the construction and working of diode. Its VA characteristics. The diode can be works an ASIC is called diode. It has two terminal device which can conduct both directions. It is bidirectional device. It consisting of four layers PN bar with two terminals T1 and T2 connect P regions of silicon separated by N region. When the terminal T1 is connected with respect to T2 layers, PN starts conducting. Then the voltage T1 is more than breakover voltage VB1. Once the conductor starts the conduct current through the diode becomes very large and is limited by the external resistance. When the external T2 is positive with respect to T1, the layers PN bar starts conducting, then the voltage T2 is more than the breakover voltage VBO2. And next, uh, in both the cases, the current during blocking regions are very small or called leakage current. The behavior in both directions are similar because the doping level is all the layers. The breakover voltage of diac is about 30 to 50 volts and the voltage drop is 3 to 5 volts. The operating characteristics of diac and triac are similar but has no gate terminal, hence it is called gate plus triac. Applications: light dimming, heat control, universal motor speed control, a triggering device of triac. And the next one, second unit important questions. Explain photodiode and construction and working. Construction. It is a device used to convert light signal into electric signal when it is connected in reverse bias. When it is kept inside a sealed metal case glass window is mounted on the top of case to allow light to enter and strike the PN junction. The two leads taken from the photodiode anode and cathode and output obtain access across load working. When no light is incident on the junction, the reverse current is zero, called dark current, and the resistance of diode is dark resistance. When a light falls on the junction, the, the transfer of energy is done from photons to atoms of the junction that will produce large free electrons which increases the reverse current. If the intensity of light increases the reverse current, increase the reverse current is directly proportional to the light incident of the junction. Advantages: low noise, good frequency response, very good spectral response. Disadvantages of photodiode: light sensitive device, dark current increases with temperature, should not exceed the working temperature limit. Applications: light detectors, demodulators, connecting, counting purpose. Applications: explain the construction and working of phototransistor. Draw the diagram neatly. It is similar to a normal transistor except that there is no electrical connection provided for base. Phototransistor produces more output than photodiode for the same input voltage. Construction. These have three regions. NPN base region is enlarged, does not have any load. The transistor is to provided with a small window on the surface. At the base collector junction, a small lens is placed on the window to focus on the light beam and concentrate on CB junction. Working. When no light is incident on the junction, the reverse current is zero, called dark current, and the resistance of diode is dark resistance. When light falls on the junction, the transfer of energy done from photons to atoms of the junction that will produce as large free electrons which increase the reverse current. ICB naught is given as IC is equal to B naught IB plus 1 plus beta ICBO. IB is equal to base of open circuit. IC 1 plus beta is into ICBO. The illumination of the light increases, ICBO increases, the transistor give large output. Hence, it is a light detector which combines photodiode and transistor amplifier. Advantages: it produces high current, low cost, simple and small in construction. Disadvantages: low voltage capacity, low speed compared to photodiode. Explain the construction and working of LDR. LDR means light dependent resistor. LDR is one of the photoconducting device. Construction: these are prepared by silicon film depositing on insulator which constitutes placed on a plastic case whose surface this covered with glass. The glass cover allows light rays to reach the semiconductor coated surface. These are usually made of cadmium sulfate or cadmium selenide provided with copper lids. It is also called as photoresistor. Semiconductor film plan, glass cover, metallic base, copper lids, evolution. Okay, next we go to working. When the LDR is not illuminated, its resistance is very high in the order of mega ohms, which is called as dark resistance of the device. When the LDR is illuminated, its resistance decreases to few hundred ohms. The resistance of the device inversely proportional to the amount of light fall on the surface. Because of the difference between the dark state and illumination state, it behaves like a switch. It acts as automatic switch whose on and off depends on illumination. Advantages: high sensitivity, low cost, ease of operation. Disadvantages: light hystery effects. narrow spectral response, poor temperature stability. Applications: light moving alarm system, light and dark activated circuit, automatic street lighting. Construction and working of LED and explain it. It is a device which converts electrical signal into light signal when it is connected in forward bias condition. Neat diagram. It is a special device type of PN junction diode made of semiconductor materials gallium arsenide, gallium phosphorus. Working. When LED is forward biased, the electrons from N type and holes in P type crosses the junction. As the result, recombination of electrons and holes takes place at the junction when releases the energy to produce photons, which emits a visible infrared lights uh, depends on the material used. The light intensity is directly proportional to current passes through LED. The ratings of LED 1 volts to 3 volts, current ratings 20 milliamperes to 100 milliamperes. Advantages: low power consumption, small in size, small in weight, sensitive to damage, wide optical bandwidth, temperature dependent. Pulse Echo Flaw Detector. Explain. Screen, CRO, near end, far end, transducer, flaw, material for detection. The detector works on the principle of affected signal inductance indication. Affected signal indication. The ultrasonic pulse uses high frequencies as 0.8 to 25 MHz, 2.5 MHz for inspection of steel, aluminum, and brass articles, but uses lower frequencies for inspection of coarse grain materials such as cast iron, uh, plastic goods, porcelain, concrete, timber, etc. Mm, The pulse echo method currently very sensitive since echo pulses for energy in small as 1% of the transmitted energy is sufficient for recording as end. Generally, a probe transducer is act as a transmitter sending it a pulse of high frequency ultrasonic into the article to be inspected and then act as receiver to receive the ultrasonic reflected from the flaw and from the far end of material. The received ultrasonics are from, formed into corresponding electrical echo pulse of same frequency as of sound. Then the reflected electrical is amplified and displayed in the form of series peeps and pulses on the CRO. The first pulse corresponds to transmit pulse followed by pulse corresponding flaw and last last place come from far end of materials and flaw pulse from the transmitted pulse give location of flaw. Advantages: the process of inspection is very simple. It is uses for the flaw detection flaw under 10 meters from deep from the surface. Disadvantages: it does not detect the flaw near the dead zone. The dead zone extends 2 to 5 nm. Strain gauge. Strain gauge resistance. The gauge factor resistance strain gauge is very high, 50 to 60 times that of metallic strain gauge. Strain gauge works on the principle a resistance wire stretches with in its elastic limit, such as increasing resistance when elongated. The strain gauge depends on the piezoresistive effect. Semiconducting materials such as germanium and silicon are used as resistance materials. The device consisting of a strain materials and leads that are placed in a protective box. Semiconductor vapors are elements which have a thickness 0.05 mm are bonded on suitable insulating substrates such as Teflon. Gold leads, the gold leads are used for making contacts. The strain gauge can be fabricated along with an IC op amp which can act as pressure sensitive transducer. Draw diagram very neatly. Advantages: high gauge factor, long life, small in size. Disadvantages: most expensive, poor linearity, very sensitive to temperature. Potentiometer. Explain. It is an electromechanical device converts linear or rational displacement into an EMF. It consisting of a resistance element provided with a sliding facility. The sliding contact is called as wiper. Its motion may be translated or rotational according to design. The rotation resistance potentiometers are used for measuring angular displacement. And draw the diagram neatly. Just reverse and see the diagram. 230 volts AC step up transformer, bridge rectifier, filter circuit, high voltage EC, Colpitts oscillator, high voltage high supply, primary of work coil, short circuited secondary workpiece, high frequency power source of induction heating, and the next one it is visible 230 volts supply, step up transformer, bridge rectifier, filter, dielectric heat, high voltage. ఇక్కడ డాటెడ్ లైన్ గీయలేదు మీరు గీయండి ఎగ్జామ్లో రాసేటప్పుడు అడిగినప్పుడు ఆర్ఎఫ్ ఆసిలేటర్ సర్క్యూట్ హై వోల్టేజ్ ఫ్రీక్వెన్సీ సప్లై ఎలక్ట్రోడ్స్ టూ సైడ్స్ వర్క్ పీస్ ట్యూబ్ హీటెడ్ అండ్ నెక్స్ట్ ఏసీ రెసిస్టెన్స్ బిల్డింగ్ 1 ఏసీ సప్లై పవర్ ట్రాన్స్ఫార్మర్ సర్క్యూట్ బ్రేకర్స్ సీక్వెన్సీ ట్రైమర్ పైన వాడింది ఎస్సీఆర్ ఆర్ ఇగ్నిట్రాన్ కాంటాక్టర్స్ వెల్డింగ్ ట్రాన్స్ఫార్మర్ ఇక్కడ వాల్యూ వెల్డింగ్ ఇది ఎలక్ట్రోడ్ రీజన్ ఆఫ్ స్పాట్ వెల్డ్ ఎక్కడ వెల్డింగ్ చేయాలో అది అక్కడ మెటాలిక్ షార్ట్ టు ద వెల్డ్స్ welding machine. This is AC resistance, this is dielectric heating, and this one induction heating. All the best for everyone. Thank you. Signing off. Bye bye.